Okay, for this video, we'll be learning how to measure volume, liquid volume, using graduated cylinders. Okay, so this is called a graduated cylinder, and this is a smaller version of the graduated cylinder too. And we'll use some different size, some really big ones, and then we use this model a lot too. Now, some things to point out with the graduated cylinder. When you're using it, you want it to be flat on a surface. You don't want it to be tilted, because obviously it's going to be harder to read the liquid measurement if it's tilted. So make sure it's flat on a surface. Sometimes your desks are a little bit tilted, so try and find a nice even desk. Okay. Other things with graduated cylinders, if you notice, there's markings. This one starts at 25 and then goes up. The next big number is 30, 35, 40, 45. So it goes up by fives all the way to 100. But then there's these little dashes. So there's 5 dashes between 25 and 30. There's 5 dashes between 30 and 35. So each dash is 1 milliliter. So this is being measured, this liquid volume is milliliters. If you have a water bottle, it's usually measured in milliliters. If it's like a big water bottle or a big milk jug or something, that would be closer to a liter. Okay, so again, we use metric for measuring volume in science class. We use metric, so that's going to be units like milliliters and liters, which are pretty big, and then kiloliters, which would be a really big measurement. Okay, I think like a water bottle is maybe like half a liter or a quarter of a liter, just to give yourself an idea of how big a liter is. Okay, so now using graduated cylinders, again, you want it to be flat on a level surface before measuring the liquid. And then, you're pouring, so use your best pouring skills that you probably learned pouring juice or something at home. You don't want to, be like all over the place and spilling. The other thing is you have to pour kind of slow, because if you pour too fast, it'll go past your number really quickly. So I want to be facing the graduated cylinder. I kind of want to be at eye level. If I'm standing up and looking down, it's hard to really see. So I kind of want to be at eye level with my graduated cylinder. And then I go ahead and start pouring. So I'm going to put in 50 milliliters of blue here. And I don't want to overdo it, so especially when I get close to the 50, I'm going to slow down. Oh, just like one more drop. Oh, went over just a tiny little bit. So I'll pour that tiny little bit out. Okay. All right, now if I'm looking at it straight on, I can see that it's at 50, just what I wanted. If I was looking at it from like an angle over here, it's really hard to see, so I want to get it eye level. The other thing is these graduated cylinders aren't too bad, but if it's a really wide graduated cylinder, the water is going to naturally curve like that. That curve is called the meniscus. A little vocabulary for you, the meniscus. And you'd want to read the middle of the curve, because the liquid kind of creeps up the sides of the plastic graduated cylinder. So you want to read the middle of the meniscus. So it's at 50 milliliters. And then if I wanted to pour in a little bit more of yellow, so let's say I want to put in 25 more of yellow. So this is, I'm going to have to be really careful because I can't unpour the yellow and blue together. And so I'm going 25 more to give me 75 altogether. Okay. All right, so that's how you use a graduated cylinder. You're just pouring in and very carefully reading the milliliters on the side of the graduated cylinder. All right, so that gives you liquid volume. Liquid volume is pretty easy. You're just pouring. Now for solid volume, it's a little bit tougher. So let's say I had an object like this Sharpie, and I wanted to find the volume of this Sharpie, so how much space this Sharpie takes up. I can't like melt it and pour it into a graduated cylinder, and I couldn't use a ruler to measure all the different angles and shapes and stuff for here. So there's a really easy way to find the volume of an unusual shape solid like this. Just drop it into the liquid. So if it's at 75 now, 75 plus the marker is going to make the water level go up. And however much it goes up, that gives me the volume of the marker. So hopefully this will work. I think it should sink all the way to the bottom. And hopefully it's not too high. Oh, it's not going to sink. So if it doesn't sink, I guess I would push it just to the edge of the water and try not to measure my finger at all. So that's going all the way up to 90 milliliters. So without the pen, it was at 75. But with the pen underwater, it goes up to 90. So 75 plus 15 is 90. So the volume of this Sharpie is 15 milliliters. I'll show you that again. So the Sharpie makes the water level go up 15 milliliters, which means that the Sharpie's volume is 15 milliliters. Okay? We'll do that a lot with rocks. Measuring the volume of rocks, we'll drop them into water and see how much the water level rises. Okay?